So now we enter into another chapter in physics, that is light, reflection, refraction. You know already the meaning of light. It is a form of energy which makes us to see the things surrounding us. Reflection means when a ray of light falls on a surface, say it is polished, you know that it bounces back to the same medium. When it bounces back to the same medium, we call reflection. Suppose there is a glass. When a ray of light travels, remember it enters into another medium, it bends. It changes its what you call direction. It bends when travels from one medium to another medium. When you draw a perpendicular line here, we call it as a normal. Incident, refraction, and this is the normal. The word we use here is refraction. When light travels from one medium to water, it bends. One water to air medium bends. On a when you are riding a bicycle, on a plain road, it goes very fast. Suppose further there is a sand for some 100 meters. There is a sand. Sand is fallen on the road. Remember, the moment front wheel enters that sand medium, it changes its direction. Front wheel changes its direction. So there we use the word changes. So in the same manner, light changes its path. It is called refraction. Here the rules: angle of incidence, angle of reflection, both are same. Incident, reflection and normal all lie in the same plane. You know it. I am going to cover in this chapter many important things. In the reflection, we are going to study convex mirror. Convex. It is, remember, if the shaded portion is outside, it is a shaded portion. If reflection takes place inwards, we use the word concave. Concave, like this, inwards. Reflection is inwards. Here also, when you draw a normal, remember I and R are equal. If we shade from inside, reflection takes place outside. Watch. It is called convex. It is called concave. There is one definite question. Remember, where you are going to get a question like how draw the image for particular object. Say this is concave, this is P, pole of mirror, central part of the mirror. When you draw from this point a curved line, it is called radius. If you complete, you are going to get a circle. If you apply some paint from outside, reflection takes place now inside. So now this acts like a radius. Radius of a sphere of which mirror is a part. It is called center of curvature. After reflection, when rays fall, they meet at a point. It is called focus. Distance between focus and the pole of mirror is called focal length. Remember, focus is capital F, focal length is small f. This is always half of this. That is why we write f equals to r by 2. If this object is on the left side, object distance is u. Object distance. Image distance is always v. Image distance. Focal length is always what you call f. Focal length. Focal length is always f. There are some rules for v, for u, for f. And if you want to compare height of what you call image and height of object, we use the word magnification. How high the object is. Even we write this one as v by u, image distance upon object distance. These are some informations. Here, after reflection, they meet at a point, converge. When the object is on the same side and one side, image is also same side, in case of mirror, we call it as a real. On the other side, if image falls, it is virtual in case of mirror. I'm not talking about lenses. Then after this, we go to image formation. How to draw? Suppose mirror, draw from this point, say 6 centimeter, draw the line, it is a P, it is beyond C. So, first you draw the object. You mark like this, shading outside. It is a parallel line. If it is 6 centimeter, mark 3. Call it as F. Take the scale, draw properly, reflection. This is center of curvature. From head, draw a line passing through center of curvature. Here it meets, it is called image. It is A dash and B dash. To remember the diagram, I will tell you one trick. You call it as the number 1, first image, object. Second, parallel. Third, reflection passing through focus. Just extend. Fourth, from head passing through center of curvature. Wherever they meet, intersecting line is below this principal. Hence, it is inverted. It is fifth. First, second, third, fourth, fifth. If intersecting line is above this principal axis, it is virtual. It is now inverted. If the size of this image is less than this, use the word diminished. If the size is more than object, size of the image is more than the object, you call it as enlarged. Or if both are same size. So how they ask the question? When you keep the object at C, next in between C and F, next at F, next between F and P. 1, 2, 3, 4, 5. Out of 5, 1 they are going to ask. This carries 2 marks. Only use compass, perfect scale and pencil. Usually you draw from C to one curve, say 6 centimeter maximum or 8. There is no exact measurement, but I am telling you. So that the image will be perfect. Don't thicken the lines. Use pencil properly. In case of convex, it is shaded inside. Reflection is outside. Again, mark point P. From here, C. Draw like this. Focus is here. You extend the line. Now, draw the object. Then draw parallel line. Here there is a confusion. It reflects here. You cannot draw like this. It is wrong. You will not get properly the image. What you have to do is, you keep the scale at F. Join like this. Then reflection. Then you are drawn from this. First, second, third, fourth, continued. Then from the head, it is fifth. Head to center of curvature. Head through center of curvature. Here it meets. Draw image. Sixth. Don't mark the numbers like this in the exam. Not required. Only to remember I have drawn. So there is only one diagram. They ask you what is the nature of the image. Always it is virtual. In case of convex, virtual. Diminished, always. Lesser in size as compared to object. It is AB, then it is A dash, B dash. Don't put the numbers. For remembrance sake, I have told you to write the number like this. So either from mirror, concave mirror, convex mirror. They may ask differences. You have to use the common sense. Reflection takes place inwards, concave. Reflection takes place outwards. Focal length is on right side. Focal length is on left side. Here, image is either same size, enlarged or diminished. It is always diminished. Here, most of the images are real. But here, always virtual. Focal length is positive, right side. Focal length is negative, left side. In this way, you can write what you call differences between concave mirror and convex mirror. Differences. They may ask. It is not there in the textbook, but you can. Like this, you can bifurcate. When they ask differences, you write columns. Now I am telling you examination point of view. In the same manner, after this, we go to convex lens. Convex lens is like this. It is a curved on both sides, bulged at the center, compact at the ends, top and bottom. It is concave. It is a thinner at the center, thicker at the edges. Thicker at the center, thinner at the edges. convex. Our eye lens, convex. It is concave. When you draw here a line, aperture, you can say. Center you mark. In mirror we used to say pole of mirror. In convex lens and concave lens we say optic center, center of lens. Here you can take C1, I mean center of curvature. You can draw this part and draw a straight line and same distance, suppose 6 centimeter, here also 6 C2. You can draw this curve. From this center of curvature, one curve. That's why I am telling you, if you draw a circle, you will get like this. You can draw a circle like this. It is a center of curvature. But instead of center of curvature, we take what you call 2 F1, F2, foci. You can take foci. 2F, it is F, it is F, it is 2F2, F1 to F1, F2 to F2. 2 foci, because 2 center of curvature, 2 F1 here. Now, when you keep the object beyond 2F1, you have to draw first object AB, draw parallel, be careful, touch to this line. You call it as 2. Here, it undergoes refraction. It changes its direction. It bends towards third. Always convex lens is towards the principal focus. And from the head pass through optic center. It is 4. Wherever they meet, this is image. 1, 2, 3, passing through F2. From head through optic center, they meet, you draw one image. Here, I have drawn a rough diagram. If you draw properly, from here to here, 6 centimeter, and midpoint, say 3, exact midpoint 3. See, there is a variation here on the board. Without scale, I have drawn. So, I may get wrong one here. But you have to write or draw with the help of what you call compass, scale. Perfect you will get. Here, see, there is a variation. Slight. That's why I may get the proper position of image. That's why what I'm telling now through this video, you draw with the help of what you call compass, scale. Perfect. You will get better, best. Next, it is the number, say 5th. Last it is. In case of what you call concave, same optic center. Assume it is 2F1, it is F. Here, beyond object, aperture, you can draw a line, center passing through, parallel. From here, you have to draw, because concave lens, it diverges the light. divergence, convergence, converging, diverging. So always draw from F, passing through. Otherwise, you will not get a perfect diagram. In case of concave lens and in case of convex mirror, pass through F because it is bending away. So I mark like this. It is first, second, third, fourth. Next, from head, it is a B, it is A. Just pass. Here there is a O. It is fifth. They meet here. Always it is virtual. Always it is diminished. Always it is on the left side. Virtual. Virtual means in case of lens, same side. It is real. It is virtual. Always virtual. Concave. Have that logic. Concave lens. If you stand in front of concave lens, your total height becomes less. And here always concave, convex lens, it is inverted. In plane mirror, same size of the object. You must know this logic. So that is why you will get 1, 2, from F, 3, 4, from head up to optic center, wherever they intersect. Always virtual. Here, focal length is on the right side. Focal length is on the left side. Focal length is always positive. Focal length is negative. It converges. It diverges. It is thicker at the center, thinner at the center. Thinner at the edges, thicker at the edges. You can write like this differences. So, in the same manner, you attempt for, try for 2F1 at between this, at F1, between F1 and O. Guarantee question. Convex lens, concave lens. Convex mirror, concave mirror. Out of 4, if you practice, you are going to get 2 marks. Definitions, definitely 1 or 2 marks. 1 or 2 marks. Definition fixed. In this chapter, it is very easy, but you must know how to use the formula properly. Now, after covering this concept, I go to refractive index. Refractive index phenomenon. That is, if you take, it is a glass. It is air. Ray of light travels, bends, again travels. There are 2 normals I have drawn. It is incident ray, it is refracted ray, it is emergent ray. It is I, it is R. When ray of light travels from air medium to glass medium, it bends towards normal. Always remember, rarer, denser. It is towards. Denser, rarer, it is away. Denser, rarer, away. Rarer, denser, towards. Here, I is greater than R. Here, I is less than R. Angle of incidence. So, this ratio of sine of angle of incidence to the sine of angle of refraction is always found to be constant. This constant is represented by n. Actually, sometimes they may tell mu, M-U-E, refractive index. Air to glass, it is fixed. Air to water, water refraction, value is fixed. Turpentine oil, value of refractive index is fixed. Diamond, value of refractive index is fixed. If refractive index value is greatest or greater, bending is very near, close and slow. That is why highest refractive index is diamond. So you must know this information. And one more thing, remember, one more thing. For N12, refraction took place in the second medium. You write this 2 first, that is V2. You write this one second, V2 by V1. N21, first is 2, you write here V2, it is V1. It is called absolute refractive index. In general, what we write is C divided by V. Velocity of light in vacuum to the velocity of light in medium is always constant. Absolute refractive index. Absolute refractive index. It is also the definition of refractive index. So in this way, refractive index, definitions, it is called Snell's law. Snell is the name of scientist. Laws are important, guarantee questions. Meaning of refractive index of glass, water 1.33, 1.5 something, 2.5 something for the diamond, 2.4, 2.5 nearing. In this way, you must be able to remember what is the meaning of that. It is given in the textbook. You can go through it. They may ask the questions. So this is how one can understand. It is emergent. And one thing remember, I and it is called E. It is air medium. It is also air medium. Both media are same. So velocity of light in air and this air also same. Hence angle of incidence and angle of emergent always same. Agreed? This is a bit theory part. Afterwards we go to solve some problems. Okay? Wait for a minute. We go to problems now.